As we mentioned over time, one of the things that mathematics allows us to do is to look for patterns and to make relationships between one object and another object. What we're going to explore in this section is this idea called variation. And variation means how one object relates directly or indirectly or through some other type of configuration with another object. There's a general problem solving strategy that I'm going to work through and I'll explain on our first example. And then also I have listed some of the different types of variations that we have. So let's look at a problem. Problem I want to look at, you ever been to Yosemite? Love going to Yosemite. I've been there in the winter, the spring, the fall, the summer. I like to go when I know that the waterfalls rushing into the valley will be at its peak. And that typically happens early summer, late spring, when the snow starts to melt. Well, climatologists helps us understand, based on the snowpack, what they can expect the water volume to be flowing down into the rivers and into the valley. Well, this one particular data set that was provided to us lets us know that 250 cubic centimeters of snow will melt into 28 cubic centimeters of water. And we know that these two things vary directly. So given that, I'm curious, well, what if we have more snow this year? What if there's a greater snowpack? How much water volume can we expect? So let's look at what happens if we expect 1,200 cubic centimeters of snowfall this year. How much water are we going to expect? Well, here's how we kind of look at doing the problem here. First of all, we recognize that it's a direct variation problem. Some value of y varies directly. This is a constant of proportion with some other value. And maybe in this particular case, I'm going to say that water varies directly with snowmelt. My first initial situation, I know that I can produce water makes 28 when I have 250 cubic centimeters of snow. The next part of this problem is that one, I want to substitute the values in that I have and then solve for my constant of proportionality, solve for my k. Divide 250 from both sides. And I'm going to get k equals 28 divided by 250, I don't know that, 0.112. So that's the relationship or proportionality factor that converts this particular situation we have. So knowing that, now I can figure out what happens if I have a greater snowpack. Well, how much water in my second situation will I have with a second set of snow criteria? So water equals my constant proportionality and the what if. What if there's 1,200 cubic centimeters that year? How much water can we predict that will occur? So I plug this, I backfill, I put my constant proportionality back into the equation with my second set of criteria numbers, and then I can multiply 0.112 times 1,200. And I get 134.4. And now my last part, I answer the question. What is the question asking? How much water can I expect if I have 1,200 cubic centimeters of water or of snow that particular winter? I'm going to expect 134.4 cubic centimeters of water. I want to make sure I label that. And does that make sense? Look at your answer and does it make sense? Lower volume, lower volume. A higher volume, I'm expecting more water. And that's the nature of a direct variation, a direct relationship.